G'day, Richard Walding back here again. I'm just going to have a look at leptons now. In the previous video we looked at the Standard Model elementary matter particles, and I looked at quarks and composites of quarks. What I'd like to do now is to have a look at leptons. That's the other type of elementary particle besides quarks. Okay, so I'll get rid of this so we've got a bit of room, and we'll just call this leptons. Now, lepton is a Greek word meaning light, or it also means like peeled, making something smaller. Now, you've heard of the word leprosy. It's a disease. It has a different name now. It's Hansen's disease, but it used to be called leprosy because the patient had skin that used to peel, and so it's the Greek word meaning to peel or light, to get smaller or be light. So these originally were thought to be lightweight particles. Okay, now again there are 6 of these. Just like with quarks, there's 3 generations and 2 members of each generation, making a total of 6, and then there are the 6 anti-leptons as well. So let's have a look at these leptons. Now you're very familiar with the first one, which is the electron. Now it has the symbol E with a minus after it. Now you're familiar with that probably from grade 8 or 7 or something like that, but you've certainly been dealing with that. Even in chemistry you deal with that. Now the first generation is made up of that thing. Now originally that's all they thought the leptons were, or these electrically charged particles like that were. So electrons were discovered back in 1890, well over 100 years ago. But as more and more experiments have been done, they're smashing protons together and so on. They're finding all these other particles as well that have similar properties. Now you don't have to know one of the fundamental differences between leptons and quarks in terms of spin. Physicists have divided them up, but we're not going to worry about that because we don't need to talk about it. We just have to talk about the different types of leptons there are. That's all you have to do. A typical exam question would be, now I seem to remember there was a question on last year's external exam. I think it said list the 6 leptons, or yeah, I think that's what a short answer question. List the 6. And all you did was that, and you get your 2 marks. Okay, so there was the electron, and there's this thing called an electron. Now I'll write the first one out. Neutrino, N-E-U-T-R-I-N-O. Now if you've done your work, you'll know from the textbook, and this is around about page 356, 357 from that book. The electron neutrino is a small particle that was predicted before it was actually found, so it's one of the great successes of physics. And they predicted it based on the fact that they needed to have conservation of momentum in particular reactions, and the only way they could account for it was a very fast moving, very lightweight particle. Now it does have mass. There's been some dispute about whether it's got mass. If it didn't have mass, it'd travel at the speed of light, but they believe it travels less than the speed of light, 0.99999 whatever c, and so it has a bit of mass. It's tiny mass. Now it has a symbol like that. It's like a V, and we put an E after it to indicate that it's the electron version of the neutrino. Now this symbol here, depending on the book you're using or the way the teacher's done it, you could just use, some people just put a V, okay, because it's hard to get the right shape. It's got a bit of a curl on the back of it, and if you look in the textbook at the font we've used in the text, you'll see it's like that, and in the syllabus you'll see it's got a bit of a curl on it. Now that's the Greek symbol nu, Nu, and so that's why they used it for a neutrino. Now all this means is, in Italian, the ino part means small, so you have a bambino and things like that. This is the small neutral one. Now neutral means neither positive or negative. It's a Greek word The NEU means neither positive nor negative. So neuter, neutral, and neutron, for instance. So this is a small neutral particle, and that's the symbol. Okay, I'll clear this up so that's out of the way. Okay, so that's the first generation, and then you've got the what's called the muon. That's MUON, and now that's got the symbol mu. It looks almost like an M when you think about it. It's sort of like an M with a long bit there, but that's the mu symbol, MU, and it's the Greek mu. So it's just basically a U with a long stroke at the beginning. Now a lot of times you'll see that stands for micro, as the prefix micro meaning a millionth or 10 to the negative 6. Often you'll see on bottles just a U because the typewriters can't type a mu symbol. So on drug prescriptions and so on, you'll often see micro moles or something, and they just use a mu, use a U. So this will be a muon. It has the symbol mu, and there's the muon neutrino. Now, again, it's that sort of symbol, like the V with a bit of curl, and it's got a mu there. And then there's the tau particle. Now these are getting progressively heavier. This is like a fat, heavyweight electron. This thing here is massive. Now these are quite unstable. This thing here is extremely unstable. Muons don't last for long. In your chapter on the muon experiment to confirm Einstein's theory of relativity, where they looked at the muon numbers at the top of the mountain and at the bottom, and I've done a video on that, these things decay in, you know, millionths of a second. It's very, very small. Okay, so you've got this tau. Now you'll notice these have got ons on the end, so this is sometimes called a tauon. Now you can either call it a tau particle or just a tau or a tauon, and it's got a symbol like a T with a little bit of a curly top on it. Okay, and then there's the tau neutrino. I won't write that out, and that it would be the neutrino symbol with a little tau. Okay, so there's your 3 generations, and they come in pairs. Now the charge on this, now this is the electric charge. I stress the word electric there because there are other types of charge. There's what's called a colour charge. Now I've dealt with that in the book. It's not in the syllabus, you don't have to know it, but it's another, well, almost like a force, but it's another quantum number. It's another quantum effect that holds quarks together. It's called the colour charge. But so I really have to call this the electric charge. Now the electric charge on an electron is -1. Now the neutrinos, as I said before, they're neutral, so they're 0. The muon is -1, and this thing here is neutral, and -1 and neutral. Okay, now that's all you have to do. It says recall the names of the 6 leptons, but also don't forget you have to define antiparticles. So it'll be wise to remember the antiparticles for this. Now look, I'll just take this down, give me some room, and I'll just do the antiparticles here. Now the antiparticle of the electron is a positron, and it would be E+, okay, because this is negative and it has the opposite charge, and the charge on that would be 1+, okay, because it's the antiparticle. Now you could also call it the anti-electron. The anti-electron and the positron, they both mean the same thing. Now some physicists would say there's a difference between an anti-electron and a positron to do with a particular aspect of the magnetic, the way the magnetism, or the magnetic, it's called the magnetic, well to you it would be just the magnetic, or the magnetization of the particle, depends, it's a magnetic field effect. So but we're going to treat the anti-electron as a positron. It's the same thing. Now the electron neutrino, there'd be, this thing is called an electron. Now I just have to be careful here. This is the anti-neutrino. Now, so it's still an electron, so it's not an anti-electron. You'll notice here it's the anti-neutrino. It's the neutrino that's the anti part, not the electron. So you put a symbol above that to indicate that's electron anti-neutrino. Okay. Now in some books, I've seen on the internet where people call it the anti-electron neutrino, and you know, enough people read that and they get confused and they think there's a difference. In the, now the syllabus doesn't mention it, but in the textbook I've made sure I've stuck to the common way of doing it, which is the calling it the anti-neutrino, the electron anti-neutrino. So this would be an anti-muon, and which would be just that, and then there's the muon anti-neutrino. I won't write all this out, and that would be the neutrino symbol, mu, and a thing over it, a bar over the top, and lastly this is the anti-tau, and it would be plus, and this would be the tau anti-neutrino. So it's the neutrino symbol, tau, and it's anti with the bar on the top. Now that's all you have to do for that. The syllabus just says list the 6 leptons. Okay, so you'd list these 6 here. You could probably get away with listing the 6 symbols, but I don't know. Some years they might get a bit funny and want you to have the words, depending on the way it's written. If it just says list the names, I'd be putting these as the names and these things as the symbols. You could put both, you wouldn't be marked wrong. As long as you, remember what I said before, as long as you match them up exactly. If you're in doubt, just put the names down. You don't have to know anything about generations, that's not a part of the syllabus. So it's just those 6 words there, 1, 2, 3, 4, 5, 6 words, end of story as far as the syllabus goes and as far as the exam goes. But you'll need to know the charges when you talk about the forces. Now look, I'll just tell you this now so there's no confusion later on. You'll notice half the leptons are charged and half are uncharged. Now these are the charged ones. Now they will be affected, they'll be affected by the electromagnetic force, you'll see later, because they're charged, just like 2 charged objects coming together. So they'll be affected by this electrostatic force or electromagnetic force. These neutral ones won't be. So what they try and trap you with in questions, and I've seen multi-choice questions or even short answer questions, what forces act on leptons? Now you'll talk about the forces, but they try and trap you with the electromagnetic force because it only works on the charged leptons. So all I'm saying here is learn not only the names but the charges so that you know which are the charged leptons and which are the uncharged leptons. And the same with these things over here. The charge on that is 0, +1, 0, +1 and 0. Okay, opposite charge because they're the antiparticles. Now there's not a lot else I can say to this. There's no such thing as composite leptons. You don't get 2 muons stuck together or 2 neutrinos stuck together. They're basically independent particles. Now you're going to see a lot of work on where the electrons travelling at relativistic speeds. They might be travelling at 0.9 c, and they have that's how they smash electrons into things to see what's going on inside. In fact, that's how they decided say a proton had quarks inside it, because it wasn't uniformly scattering electrons. Anyway, that's beside the point. So I'm going to leave that there. In the next section I'm going to do 13.2. I'll look at the forces. Okay, that's it. Thank you.